To one of the world's harshest environments, BAUER International brought its technology and expertise to contain the raw material loss problem that faced the Arab potash company APC. APC is one of the world's top 10 potash producers and a major contributor to Jordan's economy.
The Arab Potash Company is an economic establishment that contributes greatly to Jordan's economy and very well meets the objectives of its workers and shareholders.
The severe conditions around the barren Dead Sea area where APC's mining operations run strike punishing temperatures exceeding 50 degrees Celsius in the hot season. Despite that, the Dead Sea is very rich with potash minerals that make up the raw materials for APC products. This, in addition to the fact that the Dead Sea salinity is about 11 times higher than that of the open seas, make the sought-after potash salts more abundant.
Our concession area covers well over 262 square kilometers, with more than few variables to rein in year-round. The total length of our bond dike system is about 113,000 meters, so achieving a firm handle on the preservation of the resources must always be attained, primarily brine.
Natural evaporation of the water yields concentrated brine that has moved to special ponds for harvesting of the potash salts. The thicker brine is then pumped to APC's factory for final processing.
Every year, we pump about 350 million cubic meters of Dead Sea water to our pond using 4 giant electrical pumps. Unfortunately, about 100 million cubic meters of which were leaking from the pond, passing through the permeable layers under the dikes to the adjacent northbound natural channel and back to the Dead Sea.
The loss due to seepage was costing APC about 10 million Jordanian dinars annually in direct cost, and a yearly loss of about 80,000 metric tons of final product. The problem had to be solved.
The solution was to construct a wall that will cut off the seepage.
Wall cuts through the permeable layers of the earth under the dikes west to APC's man-made salt ponds. This cut-off wall is 31 meters deep, thereby limiting the flow through the permeable strata.
BAUER International FZE is part of the BAUER Spezialtiefbau Group in Germany and a world leader in the construction of cut-off walls. BAUER has successfully completed cut-off wall projects all over the world. BAUER was commissioned by Arab Potash to undertake the construction of the cut-off wall works beneath this dam.
The process of the construction begins with building a concrete leading wall to guide and align the work to follow.
The construction of the cut-off wall is composed of 3 major stages: trenching, sheet piling, and then concreting, which seals and fastens the wall in place.
Trenching starts with the grab, which takes down the excavation to 9-meter depths, where the loose soil ends on this location.
During the whole operation of trenching, slurry, which is a fluid mixture of bentonite and salt water, is pumped and kept circulating in the trench to prevent the walls from caving in and to flush out the excavated soil. While the slurry is continuously circulating, the desander simultaneously separates the excavated sand and broken rocks from the fluid. The fluid is then held in the silos to be pumped again to the trenches. Done with the loose earth, the cutter is brought into action to continue the excavation by removing the harder layers of the earth below.
The cutter mills the harder rock, taking the excavation down to the specified depth of 31 meters, keying into the low permeability soil strata. The sheet piles are the main component of the wall. They are the actual long-term barrier of the cut-off wall.
The sheet piles are manufactured by ArcelorMittal in Luxembourg and shipped to the site. As the sheets are lowered into the fully excavated trench, spaces are welded on 5 meters apart to hold the sheets vertically. When necessary, a vibrator is used to drive a sheet down to the designated level. The sheet piles connect to each other and assemble this massive underground diaphragm. The plastic self-leveling concrete is mixed at the concrete plant. This concrete type satisfies the strength, stiffness, and permeability requirements. After testing each batch, the concrete is trucked to location. The concrete is poured into the trenches on both sides of the sheet piles. Filling the trench from the bottom up, the rising concrete pushes the slurry up and out of the trench. Building the cut-off wall is concluded. The cut-off wall's efficiency is constantly and regularly monitored to guarantee that the seepage has stopped.
I was very impressed that BAUER delivered this project within contracted time and budget, with good quality and without lost time injury.
This project saves APC significant unnecessary losses and maximizes productivity, which will translate into more revenue and, in turn, strength to our economy and better enhances the shareholders' returns.
The idea of using a wall to cut off seepage might seem like a simple one, but it is far from being so. A successful construction of the diaphragm, or the cut-off wall, is a complex operation that demands planning, know-how, and precision. BAUER. Our success is beyond what an eye can see.